Well, guys, you made it to the very last presentation for Module 1. From here, you're going to take the quiz to see which stuck, and you want to do all of that before you come to class, even, yes, in week 1, because we are going to hit the ground running and learn as much as possible. But now we're really going to talk about the creepy stuff, which is somatic death, or death of the person. So somatic death is irreversible cessation of all functions, the brain, the heart, the lungs, and it is distinguished from cellular death, which occurs at the tissue level. So for nurses, we have to understand the stages and manifestation to help provide patient care, family communication, and even uh, legal responsibilities. There are different stages of somatic death. Clinical death occurs immediately after the heart stops beating, where there's no circulation, respiration, or brain activity. Biological death happens when there's permanent cellular and tissue damage due to lack of oxygen, and this begins minutes after clinical death. The post-mortem changes are the observable physical changes that happen in the body after death. And this is going to be things like cooling of the body, changes in the eyes and the muscles and the skin. And we're going to talk about those in depth. And I have some creepy pictures for you too. Somatic death. So what's basically happening here? Well, we have a stop in circulation and respiration. So blood flow stops. We end up with hypoxia, no oxygen, so basically anoxia. And we lose our supply of nutrients to the tissues. So that means we can't make ATP. Without the oxygen, cells switch to anaerobic metabolism. They go through all of their ATP stores, which of course is important for cells to be able to function and to maintain those ion gradients from the sodium-potassium pump across all the cell membranes. So what happens is that lack of ATP disrupts the function of the calcium pump, like the sarcoplasmic endoplasmic reticulum, calcium ATPase, which causes calcium ions to accumulate in the cytoplasm. And that leads to that uncontrolled muscle contraction, and it contributes to rigor mortis. So rigor mortis is that stiffness that dead bodies get. The early stages of cellular death, this is going to involve the breakdown of the cell structures and that onset of rigor mortis. So rigor mortis starts a few hours after death, and it's happening because of the depletion of ATP. Again, without ATP, the myosin heads of the muscles can't detach from the actin filaments like they should in order to relax, and so that causes the muscles to stiffen and stay stiff. Calcium continues to leak into the cytoplasm from the sarcoplasmic reticulum and the extracellular space, and that makes the muscle contraction even worse, because if you remember from physiology, that is what muscle contraction is all about, movement of calcium in and out of the cells. And then enzymes inside of the cells recognize what's going on, and they start to break down the cellular components. That is actually going to be accelerated by the acidic environment that results from anaerobic metabolism. So it starts to happen quite quickly. So early on in death, you're going to see no pulse, no respiration, unresponsive pupils, they're fixed and dilated. In your health assessment class, you guys are going to be learning how to use lights and look at pupils to see if they're fixed or they're dilated. And this is one of the ways that you're going to use that as a nurse. Their skin goes through what's called pallor mortis, where it becomes very pale. Why? They have no circulation, so no blood is getting there. And this actually occurs within 15 to 30 minutes of death. Pallor mortis happens because there is no blood, so cessation of blood circulation. When that heart stops beating, so does the circulation to all of the tissues. And the lack of circulation means that there is no blood there to reach the capillaries of the skin. And it is those capillaries in the skin that give our skin its color. So that's why it goes super pale. Gravity and blood pooling, without the heart physically pumping continuously, the blood is going to follow the path of least resistance, and it's going to pool in areas that are exposed to gravity. So that pooling of blood away from the surface of the skin also contributes to the pale appearance of the skin, but it's also going to end up causing algor mortis, which we'll talk about in a couple more slides. Oxygen depletion. The hemoglobin in the red blood cells, which gives blood its red color, requires oxygen so that it can stay that bright red color. And after death, we're not breathing any oxygen, so the oxygen levels drop and the blood becomes darker and it's less visible through the skin. And all of these things add up together to make the skin very pale, which is called pallor. Rigor mortis, this is the stiffening of the muscles, and this is actually a dead body here on a slab. See, there's nothing underneath the legs supporting them. That's just the rigor mortis. So again, without that ATP, the muscles stiffen up quite a bit. This happens within 2 to 4 hours after death. It peaks at about 12 hours, and then it starts to get less and less pronounced, so that by 24 to 48 hours, they're back to being pretty pliable. The important thing for you to remember as a nurse is when a patient dies, we have to position the body early in that process, because otherwise we can end up with some very awkward postures. So why does rigor mortis occur? Again, we lose that production of ATP after death, and that ATP, or adenosine triphosphate, is the energy molecule that's end up with myosin heads remaining bound to actin and causing the muscles to stiffen. We've got that calcium ion influx. Normal calcium ions get pumped out of muscle cells by ATP dependent pumps, but after death, those pumps aren't there anymore, and as a result, calcium ions leak into the muscle cells from that sarcoplasmic reticulum and the extracellular space, and the muscle because of that influx of calcium ions triggering the binding of myosin to actin, leading to that muscle contraction. Liver mortis. Now this is where we talked about the pooling of the blood kind of making the rest of the body pale, and you can see that on this abdomen. Abdomen is quite pale up top and pale here where he had a pad, cautery, which you'll learn what that is when you get into, or shock pads, I suppose. Could have been from that. But here you see all this purple. This is the blood accumulating in those dependent areas, and it's what gives that discoloration of the skin. It's not just in your back. Like, they will have it in their fingers, all of the places where gravity is pulling blood. That's where they're going to end up having it. Some of the factors that influence liver mortis is the temperature. The warmer the temperature, the faster this happens, and the cooler the temperature of the environment that they're in, the slower it happens. So pressure points as well. Body parts that are in contact with firm surfaces are going to appear very pale because pressure there is preventing blood from pooling. Again, looking at that rectangle here, you can see that there was pressure. So the timeline for liver mortis, it starts about 20 minutes to 2 hours after death, and it becomes fixed after 6 to 12 hours. Until up to about 2 hours, you can't even see it with the human eye. It takes a while for it to be fixed in place. So it's about 6 to 12 hours before we can actually see it. After 12 hours is not going to shift, even if you move the body. So you want to, as a nurse, always be documenting the patterns to differentiate natural causes from trauma. So if you were to see something like this, document that this pattern is on this person's. Rigor mortis, the definition is the cooling of the body that happens. The body after death gradually cools down so it matches the temperature of the environment that it's in. So the environment itself is going to influence how fast that happens, as are clothing and even the body compensation. Typically, the body temperature drops by about 1 to 2 degrees Celsius every hour after death, and there is this is where the body temperature matches the surrounding environment, and that happens within about 24 hours of death, depending on the conditions. So why is this happening? Well, again, we lose metabolic processes after we die, and metabolic processes are those that generate heat for our body. So without them, we don't stay warm. We also are going to lose heat to the environment, so conduction, convection, and radiation. The body loses heat through those mechanisms, and the conducting transfer of heat to the body's surfaces is in contact with convection. So convection involves heat loss to the surrounding air. Radiation emits heat from the body's surface. And again, without the metabolic processes needed to make those things happen. We're just losing all of our heat to on the difference between the body's temperature and the ambient air. There's what I mean by that is like if you die outside in the cold or in a cold environment, you're going to lose your heat faster than if you die outside in the so clothing and body fat actually serve as insulators so that they slow down the rate of heat loss. So a body that has more insulation is going to take longer to cool. Environmental factors, things like ambient temperature and humidity. Humid environments are going to accelerate heat loss. Think of it as like being in a desert, while warmer and more humid are going to kind of slow down the heat loss. Decomposition is the breakdown of the body tissues by bacteria and enzymes that happens after death, and it gives a greenish discoloration to the abdomen, causes the abdomen to bloat, and that's because gas is being produced by the breakdown of all the bacteria and tissue, and it also causes that nasty odor from putrefaction, which again is the breakdown of all of these substances. So we want to make sure as nurses that we're handling bodies correctly and storing other bodies to maintain some form of dignity because we know all this. Putrefaction process involves autolysis, bacterial activity, and the formation of gas and tissue breakdown. Autolysis is the breakdown of the tissue by enzymes. After death, the cells lose their ability to maintain homeostasis, so the lysosomal enzymes, which are normally contained within cells, start to break down all of the cell's components. The cell membrane will break down because of that lack of ATP. It leads to a failure of those ion pumps, so the cell membrane becomes very, very permeable, and eventually it ruptures. And then it releases the cellular contents into the surrounding tissues. So now everything starts breaking down. So anaerobic bacteria are also involved with the process of cellular breakdown or autolysis. Bacteria from the gut and other parts of the body start to grow because we don't have an immune system to fight them off. So the bacteria now thrive in these anaerobic conditions that get created by our lack of blood flow because we're dead. The protein decomposition, the bacteria produce enzymes that break down proteins into smaller molecules like amino acids, and that process releases gases like hydrogen sulfide, methane, ammonia, all of which contribute to that characteristic odor that we smell for a decomposing body. Gas is produced because there's a breakdown of proteins and other organic materials that produces gases as they accumulate within the body cavities, and that's what's making the abdomen blow up. Tissue liquefaction, basically it's enzymes and proteins, other cellular components that are being broken down by enzymes. They lose their tissue structure and integrity, and they start to turn into liquid. Like this. So what are the things that speed up or slow down putrefaction? Environmental temperature, again. So a warm environment is going to make the bacteria grow faster, and it's going to increase the speed of enzyme activity, which is going to speed up the decomposition. The opposite is true if the environment is cold, so it would slow down composition. So if you're ever watching those true crime type shows and they're talking about how long, with the temperature of the body, this is what they're talking about. That actually, a lot of times, pretty spot on. But now your job is to see if you've done their homework, okay? Moisture and humidity. So moist conditions, bacteria love them. This is one of the reasons why in living people, we try to keep things clean and dry, because if we let bacteria grow there. So moist and humidity speed up bacteria and as well. So the low humidity can actually lead to mummification. You're in a dry environment, all the moisture gets sucked out, and the decomposition is actually slowed down a bit because you get turned into a mummy instead of becoming a liquefied pool. Clothing and even the burial depth will impact this. So clothing can insulate, slow down the decomposition, or trap moisture, which would speed it up. A shallow grave exposes the body to the environment, while a super deep one will slow decomposition by reducing the exposure to air and temperature fluctuations. And then the person's body itself, a highly fat person will decompose differently person because fat undergoes a process called saponification, which is, I think if you, I'm not positive to like what language this came from, but saponification means making soap bubbles basically. So that's what's happening here. All the fat gets broken down until it forms like a soapy substance and the body just starts to. Now, a couple of other things to pay attention to is brain death. It's defined as the irreversible cessation of all brain activity, including the, and we diagnose it when somebody is unresponsive, if they have no reflexes, and we do an apnea test, and that confirms the diagnosis. The relevance is that we have, as nurses and healthcare providers, we have legal and ethical implications involved with understanding brain death and the difference between brain death and somatic death, especially when we're talking about things like organ donation. So you can be brain dead before you end up with somatic death. And we have a window of time where the heart is still beating and everything without getting any nervous response because it doesn't absolutely need it. It's going to eventually stop with the brain death, but you can have brain death for a significant amount of time, dies as well. So in healthcare, we want to, in people that are brain dead, we want to be able to use their viable organs to prevent death in somebody else whenever possible. So the test that we do, the apnea test, what we do is this is usually done for a patient that's on a ventilator, and we take the ventilator off and we see whether or not they can breathe on their own. We can also do things like monitoring for rising carbon dioxide levels, which tells us that they really don't have any respiratory drive. So they're just accumulating CO2 because their body is not really exchanging and not producing any oxygen from ATP. We can do a neurological exam, and you're going to learn how to do this in your health assessment class. So you're going to assess for cranial nerve reflexes like pupil response, corneal reflex, gag reflex. You're going to be able to test for motor responses to painful stimuli, and you need to be able to do that so that you can determine whether or not somebody has any response. If they have a response, then they're not brain dead. Ancillary tests that we can do if we are not sure. Maybe we're not sure about our exam, the neuro exam. So we can do an electroencephalogram or an EEG, and that looks for electrical activity in the brain. And we can do cerebral blood flow studies to determine whether there's absence of blood flow to the brain. So it is really important for us to be able to determine death and to follow our state and institutional protocols, which means as a nurse, that's one of the things that you are required to do. Know what your state protocols are and know what the protocols are at the institution that you work for. You have to document an accurate recording of the time and the circumstances of the brain death and anything that is done. So if we do an apnea test, if we take them off the ventilator, you're going to be responsible for recording all of that. Who did it, who was there, everything. Very highly legal process. And then you have to also, during all of that, when you're already feeling bad and overwhelmed yourself, you have to be able to compassionately discuss all of these things with the family, including informing them what's going to happen to their loved one. So these are your responsibilities. You are going to need to be able to clean and position the body, remove the tubes and catheters unless contraindicated. And you're thinking, well, why would that be contraindicated? If there's going to be any kind of coroner report, we have to leave all that kind of stuff in place. So you have to find out beforehand whether or not you're allowed to remove it. You provide emotional support and information. You've got to know and respect their cultural and religious practices, and you're going to be working with other healthcare team members for all of the postmortem procedures. So that's it, guys. You've finished this module. We've learned a ton. You're going to take a quiz, and you're going to come to class, and we're going to apply everything that you've learned.